Today we're going to be creating an Android app modeled after the classic Magic 8-ball. Before we begin, let's take a look at the final app you're going to build. Click on the app, and as you can see, just like the classic Magic 8-ball, you ask a yes or no question. Instead of shaking the 8-ball, we're going to click on the picture of the 8-ball and it will tell us the answer to our question. The Magic 8-ball has 20 different random responses that it can return to the user. Let's try it out. Will I pass Mr. Colstock's class? Question mark. And then click on the 8-ball. Yes, definitely. Okay, this app is definitely working. Okay, now to the hard part. We have to create this. Before you begin, there's a couple steps you're going to need to take. The first thing I want you to do is go to your flash drive and go into the Colstock Android directory. We need a new directory to keep all of our Eclipse projects. So create a new folder under Colstock Android called Eclipse Projects. This is known in Eclipse as a workspace. Go to the class website next and click on Android Basics. If you scroll down the page, you'll find the heading for this activity. There it is, Magic 8-ball. See how there's a link for project files? Go ahead, click on that and save it. Once it's downloaded, go to Show in Folder. You're going to cut and paste that into the Colstock Android directory on your flash drive. Click Paste, and now we want to extract all these files. This archive contains files that you're going to need while you're building this project. There's an image and there's also a font that we're going to use, and you can only get that in this archive. As you can see, there's a drawable directory with a picture of an 8-ball, and then there's a fonts directory with the font that we're going to be using. Okay, looks like we're ready. Time to put on your big boy pants. Time to create a project in Eclipse. You will realize very soon that Eclipse is much harder than using MIT App Inventor. Much, much harder. Go to the desktop, click on Eclipse. When it says Workspace, I want you to navigate to the flash drive. Go to Colstock Android and select the Eclipse Projects folder that you just created. Press OK. You really have to be patient with these tools. Sometimes they take a while to load. Here we are. We are in Eclipse. Eclipse is a Java IDE interactive development environment. And there are tools that you can add on to it to allow you to build Android apps, which are normally coded in Java. As you work through this project, you'll get much more familiar with the Eclipse IDE. Go to New Android Application Project, and you need to fill out the project creation wizard using the values I show you here. These values are also on your step-by-step instruction guide. Make sure that you're paying very close attention to every value specified here. We're going to use API 8 for the oldest Android device will support, and we're currently on API 21 as the newest, which is Android 5.0. aka lollipop. On the next screen, you're going to accept all the defaults, create custom launcher, create activity, and you're also going to store this in your workspace. Here's where you create the custom icon or launcher that goes with your app. Click on Browse and go to your flash drive. Go to the project files that you downloaded earlier. Go to Drawable and choose 8ball.png. As you can see, it makes all the different sized icons for you. On the next screen, accept the default, which is to create a blank activity. And for activity name, we will also accept the default of main activity. We'll also accept the default corresponding layout. Every screen that you see in an Android app is an activity. And there can be many different layouts for all the different kinds of devices that Android apps can be presented upon. For the next couple of minutes, you will see Eclipse struggle to put your project together. Once it's done, you should see about 3 errors remaining, and you're going to exit from the Eclipse IDE, and then you're going to open it up all over again. When you open it up again, it's going to ask you whether you want to use the same workspace you did before, and you press OK. That should be your Eclipse projects directory. And you have to be patient. If you give it a minute, Eclipse will get rid of all the errors, and you'll be ready to begin coding. As you can see here, Eclipse has worked out all of its issues, and we're ready to go. We're going to set up an emulator. Not everybody has a phone, and we certainly don't own every device that can run Android. You're going to go to the Android Virtual Device Manager, and we're going to create a new AVD, a new Android Virtual Device. You're going to specify the same values that I'm showing you here and that are on your step-by-step instruction guide. And press OK. Then you're going to start your emulator. An emulator basically mimics a piece of hardware or another program. In this case, our emulator is like a cell phone, a smartphone within the computer. It's like a computer within a computer. After a couple minutes, probably 2 or 3, your emulator will launch. And you'll see something like this. Sort of like if you just bought your smartphone. When you test your applications, you're going to deploy them to this emulator. That way, you don't need a physical device to see whether your app is working. These can be notoriously slow though. Let's create our app. The first thing we need to do is to set up some configuration values that are going to be used throughout our application. You're going to go to the resource directory of your project, and under values, there's a strings.xml file. There's a lot of different ways to edit this, but I like to edit it in the XML editor. I'm going to get rid of those 2 values, and I'm going to add 4 more. Consult your step-by-step instruction guide for the exact contents of the strings.xml configuration file. When you're done, Control S to save your changes. These values will be referred to elsewhere in the code, and by putting them in a configuration file, if they ever need to be changed, we'll change the file. We will never hard code important values in our program. Next, we're going to edit the dimens.xml file. This is a configuration file that stores all of the different information about the sizes and dimensions of things in our program. We're going to change the default horizontal and vertical activity margins to 8 dp, and we're going to add a couple more lines. Again, consult your step-by-step instruction guide for the exact values that should be in the dimens.xml file. Once again, these will be used elsewhere in our program so that we don't have to hard code values. This is really helpful to be able to change something in one place and have it affect everything else, instead of having to track down all the places that we used a certain value in our programs. Next, under the resource directory, we're going to go to the menu directory, and we're going to update the single entry, the single item entry. Where it says action settings, we're going to change that to action quit in both places. This file stores information about what menu items are in the action bar in the main menu of our app. For our app, we're going to have one menu item, and it's going to simply say quit. When the user presses quit, it's going to quit the app. Make sure you press Control S and save the contents of all of these configuration files. Now we're going to build the layout, what the screen actually looks like. It's very similar to MIT App Inventor 2 with some twists. Go to the layout directory and click on where it says activity main.xml. You'll see that there's two different ways that you can modify the layout or what your screen looks like. You can hard code it using XML, or you can use the graphical layout. Just like in MIT App Inventor 2, you're going to drag components from a palette onto a designer, and you'll be able to see all the components as a hierarchy in the screen to your right. Let's start by deleting the text view that Eclipse makes for you by default. And now we need to change the layout that remains. Right-click on it and choose Change Layout. We're going to change the type of our layout to be linear vertical. Linear layout vertical. Press OK. We're also going to make some other changes. We're going to change the name to Parent Layout. If it asks you at any time to update references throughout the code, press yes and then OK. Just like in MIT App Inventor, we're going to update things such as the layout's width and height. The choices are very similar, in many cases exact. Refer to your step-by-step instructions to accurately set the properties of all the components that we will add to our screen. As you can see here, we use pre-stored values instead of hard coding for the dimensions and for many other things. The dimensions we're specifying for margin are actually stored in our dimens.xml file. You will see us use this same technique to refer to strings that we put in the strings.xml file, so forth and so on. Underneath our parent layout, we're going to put a series of horizontal linear layouts. The first one is going to be for the user input. Once again, refer to your step-by-step instructions for the exact values of each property. One of the things you'll notice is that when we name items, it'll say plus ID. What that means is that Java, the Android platform, is going to create IDs, unique identifiers, for anything we put on the screen dynamically at runtime. Right here in our margins, as you can see, we're once again referring to previously established values for dimensions. In order to streamline development, you will see the use of this at value, at dimen, at string, at Android. And these all refer to previously established values that we can use throughout our program. As you can see, as a platform, Android is obsessed with not hard coding any values, any strings, any numbers, not even hard coding the size of components. In the user input layout underneath, we're going to have a plain text component, and this is where the user will type their question. Once again, when you name something or rename it and it asks you to update references, you should always select yes and OK. This will update all references to this component elsewhere in your project. Here we're going to specify a hint. This tells the user what to type into the field. Once again, @string, and this is going to be user input text. Once again, we're referring to values we set up earlier in the strings.xml file. This makes our application configuration driven and very easy to change. For colors, you can use previously configured values available through Android, especially for simple colors like black or gray. That's what we're doing here. I know this is an extremely tedious process, but it's definitely necessary. Using the graphical layout, for some people is easier. For some people, they would rather modify the XML directly, which is the other tab that says activity_main.xml. When you finish entering all the properties for the 8-ball user input text component, we're going to need to create a new directory. And we're going to create a new directory under the resource directory, and we're going to call it drawable. Drawable means in Android pictures, something that can be drawn on the screen. What we need to do is go back to our flash drive and navigate to the project files we downloaded earlier. As you can see, there's a drawable directory. We're going to drag the 8-ball image from the drawable directory of the project files over to the newly created drawable directory in our app. When it prompts you to copy the files, press OK. And as you can see, in your new drawable directory, there is now an 8ball.png file. We need this for the next component that we're going to add to the layout. The next component is actually an image button. An image button is just a button which happens to be an image that when you click on it, you can respond to it with code. Go to Images and Media, and you're going to drag an image button onto the designer. I almost never get this in the right place, but it should be right next to your input text box. It's going to ask you which resource do you want to use. We want to use the 8-ball. The 8-ball is that drawable image that we added earlier. If for some reason your 8-ball doesn't go exactly where you want it, feel free to move it up in the hierarchy, just like I did. It should sit right next to the 8-ball user input text box. Following your step-by-step instructions, you want to set all of the properties for the 8-ball button. Press yes and OK to update all references once you've changed the name. This one's a little bit different in that the width and height we're going to get from our dimen.xml file from values that we set up earlier. What's great about this is if we ever want to change the height or width of our 8-ball, we can do it in the dimens.xml configuration file, and we don't have to track it down in the code. Make sure you pay special attention to the properties of this component, because this is the component that the user actually clicks on. So you want to make sure that the onClick property is set appropriately. Make sure you double check all of the properties as you set them and before you move on to the next component that you place on the layout. So far, you can't even see the 8-ball on the screen because the scale type is what needs to be changed to fit start. Once we set that, the 8-ball, you can see it. And here's the most important one, the onClick event. This is going to call a method that we're going to write called shake 8-ball anytime the 8-ball is pressed by the user. Double check and make sure this is spelled correctly and that it's present before you move on. At this point, you should have a pretty good idea on how to use the graphical layout and how to set properties for components that you put on the page. I'm not going to bore you by showing you step by step, keystroke by keystroke, how to put together the layout. Everything you need is in your step-by-step instructions. Follow that to the letter, and you should be in good shape. Hopefully you've added all of the components to the layout, set all the properties, and hopefully your layout is starting to look like what you see here. For the next step, we're going to update the theme that we use in our app. From the drop-down, go to Holo Light, Theme, Holo Light, Dark Action Bar. This will update the theme to the one we want to use. Afterwards, make sure you press Ctrl S to save. Once you press Ctrl S, you'll see the Magic 8-Ball now shows as the title on the layout. At this point, our layout, what our app is going to look like, is done, except for we need to add a custom font. Now this is the type of thing that isn't possible in MIT App Inventor 2. In order to do this, we're going to go to the Assets directory and we're going to create a new folder underneath it called Fonts. In that Fonts folder, we're going to put the font from the project files you downloaded earlier. It's called Skater Girls Rock. Go back to your flash drive, to the project files, go under the fonts directory, and you're going to drag the Skater Girls Rock font file into the fonts directory you created under the assets folder. You should be able to see it in your project, just like you do there. This is a simple Android app that has one activity. I've written the code for you because it's fairly complex. If you go under the src directory, you will find all the source code. Under the com_colstock example 8-ball package, you'll see that there's a main activity class. That class has a couple of methods: onCreate options menu, so forth and so on. I've updated all this code to create a functional Magic 8-Ball application. All you have to do is go to the class website, grab this code, and replace that class. When you go to the class website, there's a link to a gist. You click on raw and then Control-A, Control-C to capture the code, come back to the main activity class and replace what's there with what you got out of the gist. Control-S to save. And at this point, your project is ready to run, test, and deploy. Take a moment as well to read through all the comments. You won't understand what all of the code does, but you should be able to follow some of it given the limited experience you do have. Next thing we're going to do, we're going to test our project on the emulator that we created earlier. To do that, you click on Run As, and you choose Android Application. I'm assuming that you already have your emulator up in the background from earlier, but if not, you'll need to launch it using the Android Virtual Device Manager. It'll take a moment, but once it compiles and builds your application, it will deploy it to your emulator. If you're asked to, you might need to select your logcat settings. Let's try it out. Let's ask our Magic 8-Ball a yes or no question. Will Mr. Colstock get mad if I act like a #freshman? I think we all know the answer to this one. Now click on the 8-Ball. And it says don't count on it. As you can see, our app is working as intended. Let's ask another question and make sure that the randomness of our app is what we want it to be. Will Mr. Colstock get mad if I steal his chips? Most likely. Okay, one more. Will Mr. Colstock's eyes explode if he has to do one more screencast? Yes, definitely. Now this app works. All right, we're almost done. As you can see, the emulator, it's a little slow, a little clunky, but it gets the job done. But we need to test it on a real Android device in the real world. The APK for your project can be found in the bin directory. Every time you run your Android app, it goes ahead and compiles this APK for you. Go ahead and log on to your class website by FTPing with FileZilla, and all you have to do is drag from the Eclipse project into the FTP window. After all, this is Windows, and it will upload the APK to your class website. Once again, simply drag it from the bin directory where you find the APK into the remote site window of FileZilla, and it will put it on your website. Make sure you put it in the public HTML folder. Then go grab a device or grab your phone, navigate to your class website, and click on the APK that you have published out there. That'll download it to your phone where you can install it. Click on the installed APK, go through the prompts, and open it to test it on a real-world device. Go ahead and ask it a yes or no question. Click on the 8-Ball, make sure everything's working fantastic. I'm getting a little bit tired, so I went ahead and tried to do some voice recognition. Of course, it doesn't know how to spell as well as I do, so I'm going to go back and fix that. Our computer class is all this boring? Question mark. When I click on the 8-ball, it says signs point to yes. As you can see, the Magic 8-ball. It works. It's a classic. Thanks for hanging in there. You've created an Android app using an enterprise tool. You should be proud of yourself.